Now, on page number 2, we're talking about measuring instruments or measuring device. Okay. So again, let us start with length. Okay, so let's start with length. Where length, I want you to read the sections on your own. Make sure that you understand the specifics. That's why it's there, not just for decoration. However, let me just explain to you the different equipments used inside specific physics labs in order to measure this physical quantity. First one is length, and the symbol for length is letter L. So that's letter L. Some of you might say, oh, so letter L should be like this. Okay, L. But make sure it's lowercase l. Equipment for measurement. Of course, we use what we call the ruler. And how long is a ruler? Some of you would say it's 12 inches. Yes, that's the English system. However, in terms of metric ruler, that is 30 centimeters. Now we have a meter stick. So meter stick. A meter stick, how long is a meter stick? That's why it's called a meter, because that's why it's called a meter stick, because it's 1 meter. Now ruler, why is it called a ruler? Information would tell you, trivia, is that the ruler would have approximately a size of 12 inches in terms of their shoe size or their feet. So that's why it's called a ruler. So 1 rule. Meter stick, also another equipment that we use to measure, is called a tape measure or measuring tape. So it's okay to pass the table if you're going for information. Okay, next one is your mass. Okay, so mass, which is letter M. What is the device to use to measure mass? So first one is a digital scale. Digital scale, and then another device that we use that is common in chemistry is called a triple balance. Okay, if you want to see a picture, you can Google this and you can see an example of a triple beam balance, but we do have it inside the lab, especially in chemistry. I used to have one, but now I seldom use them because specifically we use digital scale in physics. Time, which is measured in terms of t or represented by lowercase t. Time, we use what we call timer or what we call a stopwatch. So it's something that you can turn on and off, stopwatch. Electric current, which is I. It says there we use ampere, so the measurement is in terms of ampere, so we use ampere meter. Or sometimes we can see it as amp meter. So instead of writing the whole phrase ampere. Last but not least is your temperature. T or T. Temperature, make sure that you know that when you're talking about temperature, it's also the same as time, but this time we're talking about temperature. So we have the thermometer. Thermometer, some people pronounce it thermometer, some people pronounce it thermometer, some uses the phrase thermometer. I would say that's acceptable, however, thermal meaning energy, so that's why we don't use it. So thermometer or thermometer, sometimes we use other devices like pyrometer, which is higher temperature measuring devices. But for our case, in our lab, we use thermometers. Okay, so that is your physical devices that we use. Okay. I'll see you on page 3. Let's pause and then let's go to page 3. Now let's continue with page 3. Okay, page 3. So the comparison between scalar and vector quantities. So vector and scalar quantities. So let's start with the most common one, which is your scalar quantities. So what I'm going to do, I am going to divide the page into two. Maybe it's a good one. But before that, why don't we talk about things first? Okay. What's the difference between scalar and vector quantity? So let's just divide a first section of it. Scalar and vector. Okay. So vector quantity. So what are some of the similarities? So what's the similarity between the two? Of course, both of them are quantities. Okay. Quantities, and if we talk about quantities, when we talk about quantities, there's what we call magnitude. So both would have magnitudes. So let me just write it down. So magnitudes. So what is a magnitude? Okay, what's a magnitude? Is basically the amount. So magnitude is amount. So how much? So it's a question of how much. Okay, how much? So it answers that question, how much. For example, how strong? Okay, how strong was the earthquake? 4.5 magnitude. Okay, so how much? Okay, how heavy? So it answers the question how much. It's the amount. The second one, what's the difference between those two? Now this time let's talk about the differences. Aside from the spelling, which the other one starts with the letter S while the other one starts with the letter V, scalar quantities doesn't care about direction. Without direction, direction does not matter. While here, direction do matter. So let's say with direction. So quantities with direction. Quantities with direction. So the amount and then the other one's direction. Now, how do we specify direction? The most common one that we learn is that we have north, south, east, and west. Okay. North, east, south, west. If you go around in circles. North, south, east, west. So stop from the top, going to the bottom, right, and then left. So that's how you know the order. Okay. Now, in math class, we add some numbers. Okay. In math class, we add some numbers. So what is the angle when it's on the right side? This is quadrant 1, this is quadrant 2, this is quadrant 3, and quadrant 4. And usually it starts with 0 degrees. Right here is 90 degrees. Right here on west is 180 degrees. And then the bottom part is 270 degrees. And then if it repeats the process, now it's 360 degrees. So it actually goes around in circle at 360 degrees. So direction can be in terms of north, east, south, west, or it can also be represented by 0 or angles. Okay? Now, what are some of the examples of each type of quantity? So let's divide this page into half. So let's say I have 5 meters per second. 5 meters per second, we all agree that this has something to do about rate because it's divided by time. So anything that is divided by time, that is considered rate. Divided by time, 5 meters per second. So this was divided by 5 meters per second. Now, this is a scalar quantity because it's not specified where is it going. Now, what if I would say 5 meters per second and the direction is east? or I would say 5 meters per second, and the direction is 0 degrees. Now, another tricky part is I would write it here 5 meters per second. So we have 5 meters per second, and then I will change this into positive. Okay. I would change this into positive. Now, this is a little bit complicated because sometimes you might say 5 meters per second positive. As we all know that in our math class, when it's going upward, that is also positive. When it's going to the right, it's positive. So this can be a little bit confusing to some because we don't know what is positive and negative, or what specific positive are we talking about. Is it going upward or going to the right? Then if not, then there's a specific difference between those two. Okay, so 5 meters per second, this is usually called what? This is your speed, because direction does not matter. When direction does not matter, it's called the speed, so that's a scalar. Now, all these three is what we call velocity. Okay, so velocity. So velocity is basically the speed with direction. So if you're moving forward, if we don't talk about the direction going forward, then that's just the speed. If we're saying 5 meters per second backwards, then we're going to the opposite direction. So therefore, that is considered the velocity. Now, for this case right here, when it's positive, since velocity starts with the letter V, so what do you think is the symbol for velocity? The symbol for velocity is V, the italic V. Okay, italic. Okay. Italic. So it needs to be italic. Italic. So V. Now, in order to specify if it's either on the x-axis, which is also known as the horizontal axis, horizontal, x-axis, or y-axis, so therefore we put a subscript of Vx. And then it's a vertical axis, vertical motion going upward, so that's y-axis, so that's V sub y. So if you specify that this is V sub y, so therefore it's meaning it's going up. However, if we're talking about V sub x instead of V sub y, then it means it's going to the right. Okay. Velocity. Now, a very controversial measuring device or measuring unit or measuring quantity is what we call 5 kilograms. Okay, 5 kilograms, and then on the other side, we're talking about 5 newtons. So 5 newtons, also known as 5N, so 5 newtons or 5N, which will be one of the topics that we're going to learn in this class, and you need to know this because this is physics. So 5 kilogram is basically mass. And there's two types of mass. Okay, there's two types of mass. You can talk to your chemistry teachers, you can talk to your bio teacher or life science teacher, and a lot of our colleagues in the science department have some confusions on the difference between those two masses. There's what we call the matter mass, which is the amount of matter, and then the second one is the inertia mass. Okay, has something to do about the equation mass or force equals mass times acceleration. Now, we have 5 newtons. Newtons has something to do about your weight, because when we talk about weight, it is going downward to us. However, the direction of downward is always relative to the location of that person. If you are on the northern side of the northern hemisphere, definitely it's going down based on your observation. But if you are in the southern hemisphere, you feel like it's going down, but basically if someone's observing from another location, it's going up. So that's why we see things the way we see things, and that's why it's very important that we know what we're talking about as your frame of reference, which is our topic in the next couple of weeks. Frame of reference is also very important. So this is your example for weight. Last but not least, we can talk about 5 meters. 5 meters in physics, it can either be length. So length is your displacement. Length is your measurement. So for example, how far is your house from the school? Most of us will say 5 minutes walk. When I'm not asking you how long. So the question is how far. So when the question is how far, we're talking about specific distance. If they ask you how long will it take you to come to school from house, how long is your travel time, then we're specifically asking for time. So how long is the this one is how far. It doesn't matter what direction. The other one is 5 meters. Let's say going north. 5 meters north. Or I could say 5 meters. The angle right here. 5 meters north is 90 degrees. So therefore that is 900, or that's 90 degrees. Okay, 90 degrees. So the direction of weight is always, let's say 5 newtons downward, or 5 newtons 270 degrees, because it's right here. So meaning later on, as we go on with our study in physics, you know that 270 degrees and the cosine of 270 degrees is 0, but the sine is -1. So -1, so meaning if we multiply, if we figure out the direction, this will give us a negative direction. I'm sorry about that one. So negative direction, so it means it's going downward. So if we have 5 meters of 90 degrees, that is what we call, or well, this one is distance. So we're trying to measure distance right here. So distance, while the other section, this is not distance, but it's called displacement. So when there is a direction, it is not a distance anymore. So now if it's either going to the left or going to the right, so it's a displacement. So traveling to and from is basically different from each other. So that is page number 3. And now we're going to go to page 4, 5, and 6 for example and procedure and how to convert units. So let's just pause and move on with the next part of the lesson. So now we are on page 4. Okay, page 4. The process on how to convert units. Okay. Now, before we move on specific on how to convert units, what I wanted to do is to go over. Okay, is to go over unit of time. So let's write about time. Okay. Conversion of time. So conversion of time, since we all know that in metric conversion, everything is in terms of tens. Okay, so you start with the baseline, base. So for example, what is your base unit? We have base of length, that is in terms of meters. Base of mass, of course that will be G, so kilogram. And then last but not least is S, which is in seconds. So these are the base units. Later on, as we move on with our lessons, we will learn that, oh, there's liters. So we have milliliters, we have centiliters. Okay. So those stuff. Now, let's talk about time. Okay. In the Olympics, the most recent one in Paris, most of the time, the difference between two athletes, for example, two swimmers, sometimes a winner might be ahead of 0.1 or 1 millisecond. Okay, so millisecond. So this is the most common one, which is millisecond. So let me just use a different color pen, my red pen. 1 ms stands for millisecond. So the word is milli. To some, you might say, "Oh, milli 1,000 is a million from the word milli," but it is not. Milli stands for 1,000, so it means you have to divide it by 1,000. So that is 1 over 1,000 of a second. So this one will change into decimals. So 1 millisecond is 1 over 1,000, or let's just copy it here. How many zeros do we have? 0, 0, 0, and then 1. Or we can say that's 0.001 second. So that's technically this one right here. So 1 millisecond is equivalent to 0.001 second. Now, convention, okay, about from the smallest one, which is seconds, 2 minutes, and then to H, which is hours. Okay, there are 60 seconds is equivalent to 1 minute. As you can see. Now there are 60 minutes into 1 hour. But at the same time, if you multiply 60 and 60, how many hours or how many seconds are in 1 hour? So we can say 60 times 60 is 3,600 seconds is also equivalent to 1 hour. Okay, so make sure that you are aware of those different measurements. So we have milliseconds, so converted to 0.001, so that's the metric conversion of time, and there is the conventional conversion of time, and that is from second to minutes, from minutes to hours, and seconds to hours as well. Or you can go the opposite direction, 1 hour to, or let's say half an hour into seconds, which is simply 30 minutes, and then 30 minutes into seconds, so 60 times 30. So we come up with an answer. Now, this is for metric. Trivia. So I just wanted to add some trivia. How do you write second if we're talking about the English system in your math class? So math class, the imperialist system. So math class, it's called the English system. So English, when we talk about seconds, that should be represented by SEC. Minutes, MN, and then hours is HR. So that's the difference. Okay. So S, M, S, min, and H is for the metric system, like here. Okay. That's your metric system. Oops, we have to include H. Compared to our English system. So take note of this observation in your math class. Why is it Mr. Rivera uses S, min, and H, but how come in my math class the teacher uses SEC, minutes MIN, and hour uses HR instead of H? Like Mr. Rivera's class, we use H. Now let's move on to page 5 for the process on how to convert units and some examples. Now let's move on to page 5. So this is your page 5. I know you start with a very blank page. Okay. So let's say I wanted to convert. Okay, I wanted to convert. Let's use this as an example. 25 centimeters. And I wanted to convert this to, how much is this in terms of meters? So we're going to the base. Okay, we're going to the base. So every time you convert, you always go to the base unit, and that is either meters, grams, or seconds. Okay, meters, grams, or seconds. Seconds, very seldom, because it's only going to be milli. You're not going to use any other prefix. Okay. Now, centimeters. What is step 1? Okay. Step 1, Step number one. Step number one. Step number one is to copy the given and change to fraction form. Okay, so let's change it to fraction form. Step 1. So what is the fraction form of 25? How do you change it to fraction? So 25 over 1. So you divide it by 1, it stays the same. The unit is centimeters. How do you change it? How do you change it to fraction without changing it to a different unit? That is by dividing it by 1. So now it is 25 cm divided by 1. 1 times 1 is how much? 1. So 25 cm. So I'm just writing it there. Step 2. Step 2. Okay. Draw a multiplication symbol. So that's step number 2. Multiplication symbol. Okay, step 1. That is 25 cm, and you change it to, by the way, this one is 25 cm over 1. Okay, 25 cm divided by 1. And then you multiply it by, draw the multiplication symbol. So that's step number 2. Step number 3. Step 3. What is our next step? Simple. Draw a fraction line. Okay. Step 1. Copy the given and change it to fraction, 25 cm. Step 2. Draw the multiplication symbol. Step 3. Draw a fraction line. Now, step 4. Let's do a step 4. Step 4. It's getting very simple. Step number 4. Afterwards, let's cancel the units on the top. Okay? Cancel the unit at the top. So, step 1. Well, let's write the procedure. Cancel the unit by placing the given unit at the opposite side. Okay, opposite, or sometimes some of you like to use some complicated word, which is inverse. Unit at opposite or inverse location of the line. Okay, here we go. Now, start with step number 1. Copy the unit, the given, and change it to fraction. Draw a multiplication symbol. That's step 2. Step 3, draw a fraction line. Step 4, try to cancel the unit, which is cm, by placing cm on the fraction line in the opposite side. Since cm is on the top, let's place cm on the bottom. And then if you go back to the given, we want to convert this into meters. So therefore, let's wait for it to refocus. Let's wait for it to refocus. Let's wait for it to refocus. There we go. cm and then meter will be on the top, centimeters, centimeter cancel out. Now let's proceed with step 4. Step 4. Oh, now let's do step number 5. Step number 5. Step number 5. Yes. Before we go to step number 5, okay, step number 5, let us plug in the conversion factors. Conversion factors. Now, where can we find conversion factors? Conversion factors are in page number 4. Page number 4 of your notes, which is right here. Okay, page number 4 of your notes. So these are the numerical values of it. Okay. Now, let us move on. Let's use those conversion factors. Okay. Step number 1. What is step number 1? Copy the given and change it to fraction by dividing it by 1. Step number 2, draw the multiplication symbol. Step number 3, draw a multiplication line or fraction line, I'm sorry. And then step number 4, okay, you place the unit by, you cancel the unit by placing the given unit at the opposite side or the inverse location of the line. So centimeters on the top earlier, now it's centimeters on the bottom. So it cancels out. So if you go to page 3 and look at conversion factors of centimeters. Centimeters is times 10 to negative 1. So meaning that is 100 and then over 1 over 100. So it's 100 or 0.01. So where will we find 100? Where can we find 100? The 100 should be at the bottom. So there are 100 centimeters for every 1 meter. Okay, so that will be almost the final step. The final step is step number 6. Step number 6. And that is simplify. Math operation. So let's simplify math operation. But before we do so, okay, step 1, given, change it to fraction, divided by 1. Multiplication symbol, fraction line, opposite location of the unit, centimeters and then meters, and then copy down your conversion factor. So centimeters and centimeters cancel. So 25 times 1, that's 25. You divide it by 100. So that will give you 0.25 meters. So this will be your final answer. So basically this one is a 6-step process, and the last one is to just simplify the operation or the math operation. And this is how simple the process is. Okay, so I will give you additional example, but this time let's use different examples, but we don't have to write the steps, but instead just give you some ideas on how to do so. Okay, so let's go to page 6, and I will just pause this video, and then afterwards we'll continue to page 6. Okay, so page 6. Example number 1. Let's say I have 15 meters, and I wanted to convert 15 meters to, to centimeters. So how many centimeters are there in 15 meters? So step number 1, so we don't have to write the procedures, let's just follow the step by step. Step number 1, copy down the given, and then we divide it and change it to fraction by dividing it by 1. Times line, and where can we find the meters? It's on top, so therefore on our line we should place it on the bottom. That cancels out our meters. Centimeters on the top. Conversion factors. Okay, conversion factors. So meters to centimeters. So from here, okay, here to this one. So for every centimeter, there is 100 meters. So therefore, for every 1 meter, there is equivalent to 100 centimeters. So now it's the opposite of the example we did on the step. Now all we have to do is multiply 1,500. So that will give us how many zeros? 1,500 centimeters. So there are 1,500 centimeters for every 15 meters. Okay. Simple. Now let's move on with a much, okay, let's add some more steps on this. What if, okay, what if I wanted to convert 15, or let's say 1 kilometer to centimeter. Okay. Kilometer to centimeter. So you don't get confused by looking at both numbers. So now, let's change kilometers to centimeters. So, step number 1, let's copy our given and change it to fraction by dividing it by 1. 1 kilometer over 1. And then you put your multiplication symbol, draw the bar, or draw the fraction line, and then let's cancel kilometers by going down right here. Now the problem is, there is no direct conversion from kilo to centimeters, but instead we have kilo to base. It's always about base. So first thing that we should do is to stop with the base. And what is the base of kilometers? It is meter. So now my kilometers or kilometers cancels out, and there are 1,000. According to the table in page 3, there are 1,000 kilometers going to the base. 1,000 kilometers going to the base. So that's why we have 1,000 right here. Now, we don't want an answer in terms of meters, but instead we want an answer that is equivalent to centimeters. So let's do another step. Let's cancel meters. So meters will be in the bottom, centimeters on the top. So now meters and meters cancels out. So now what we have left is your centimeters. So if this is centimeters, so meaning there are 100 centimeters for every meter. Now we can just simplify it by multiplying 1 by 1,000, which is 1,000, and then you multiply by another 100. Okay, so therefore we have 100,000. So 100,000, and the new unit is centimeters. So we were able to convert it by doing 2 steps. Okay, so steps, step by step. Now let's do another example, but this time let's have an example having a fraction as a unit, but not the number. For example, I have 5 kilometers per hour, and I want to convert this to meters per second. So meters per second. So meters per second. So this time we might need a calculator, or to some of you who are very good in numbers might not need any calculators for this. Okay, so step 1, let's copy the given and change it to fraction. If you notice, the unit is already in fraction form. Numerator is kilometers, denominator is, so this is our numerator, and this is the denominator. numerator and denominator. So let's convert this. So 5 kilometers per hour. So we can just extend it to 1. Because if you multiply 1 hour, 1 times h, so that's 1h or just h. Bar, where can we place our kilometers? Bottom. How about our hours? So kilometers into meters. So we have 1,000 meters divided by 1 kilometer. So we can cancel our kilometers. So meters per hour. Oh, so we're not done yet. So now we have to convert this into seconds. So hours to second. So if you go back to page number, I kept on saying page 3. It's not page 3, but it's page 4. I'm sorry. So now let's go to page 4. That was my mistake. I was saying page 3 all the time. It was page 4. Okay, so let's convert this into hours. Hours into seconds. So let's use this number, the conversion factor. So we have meters, and I'm happy because that's what we want in terms of distance. So now let's change time into second from hours. So hours is on the bottom, so therefore let us put hours on the top, converting it into seconds because we can cancel those hours. Now seconds is at the bottom, so we have meters, seconds based on our given. Okay, so for every 1 hour, there are 3,600 seconds. So all we have to do is simplify this by multiplying 5 by 1,000. So let's try it. So 5 times 1,000. So I'm using my calculator right here. So that is 5,000. Let's divide it by 3,600. And that will give us a speed of 1,000, 1.388, or let's just put 0.39, okay, meters over seconds, because there's no other units. Everything was canceled, so just meters per second. So meaning we were able to get the answer because the units are the same. Thank you for paying attention in today's lesson, and I'm sorry for some of the technical issues that we had earlier on the first couple of pages.